Okay, I don't know how I'm gonna get away from wearing my headphones this time because probably gonna be watching videos, which I guess is fine, but obviously not ideal. So instead of last time I was working on Godot, I was just doing GD script, doing the little like tutorial test exercises that they had. This time I'm just gonna try and like watch some beginner's guides. This is Net Ninja.
Hello there! In this tutorial, we are going to create a space shooter in Godot. And while making the game, I'm going to explain Godot from scratch, so you don't have to have any previous knowledge. Although, before that, let's cover some basics. Most importantly, Godot is a game engine, and it is somewhat similar compared to other game engines like Unity, Unreal, or Game Maker. They all ultimately work in the same way, in the sense that they are giving you the tools to make games. This would include creating graphics, getting input, playing sounds, covering physics, exporting the game, things like that. If you combine all of these things, you hopefully get a game out of it at the end. The really nice thing about Godot is that it is completely free, community developed, and open source, which means there's no chance of anybody raising the prices, like for Unity, for example. And since it's free, it's also really easy to get started, which is why it's becoming so popular recently.
That Unity thing.
Let's install it right away. The website you want to go to is called godotengine.org. And on there, you can see it right away. You want to click on Download Latest to get Godot version 4.2. Now this version is super recent. As a matter of fact, it came out while I was making this tutorial. So for the videos, I'm going to work in Godot 4.1.3. But it really doesn't matter. The differences are much more advanced and are not going to affect this tutorial whatsoever. So simply click on Download Latest, and then you should be getting this page, where Godot gives you the right version for your operating system. Godot is available for all the major ones, so Windows, macOS, and Linux are in there. Right now, we don't have any projects. So Godot is trying to open an asset library, but we don't want that, so click on Cancel. Now, this at the moment is entirely empty, but later on, once you have a few projects, they would show up in here.
Sorry, I'm gonna swap this to dark mode. I thought I already did that, but I guess not. I don't remember. Hold on. Refresh.
Godot gives you the right version for your operating system. Now, we don't have any projects. So Godot is trying to open an asset library, but we don't want that, so click on Cancel. Now, this at the moment is entirely empty, but later on, once you have a few projects, they would show up in here. But at the moment, we don't have any of that, so I want to create a new project. And now we are getting a couple of options. Most importantly, we need a name for our game. I want to call it Space Shooter. After that, we have to create a project folder. I am going to do that in my Documents folder, but if you have your own setup, just use that. Also, the files you downloaded for Godot, you probably also want to store somewhere outside of your Downloads folder. But anyway, once you have your setup, you want to click on Create Folder. And then Godot is giving you a tick, and that's a good sign. After that, we have to choose a renderer, and there we can choose between Forward Plus, Mobile, and Compatibility. I would recommend to choose Forward Plus, although for our basic game, the differences really do not matter. They do start to become important when you get to 3D, but that's not what we are going to do, so choose whatever. And after you've done that, go to Create and Edit. Then Godot is going to load for a second, and after that, we can see the Godot editor. Now, I am going to explain all of this in
More than a
detail in
second.
just a bit. But before we get to that, I want to make a few changes. And that happens under
There we go.
Editor and Editor Settings. Specifically, under Theme, you can get a custom color. I do not like the default bluish color, and Breeze Dark I personally find significantly better. It takes a few seconds to load, but after that, you get much more neutral gray colors. Although the choice here is fairly personal, if you want to have a light theme, that would also be in there. On top of that, in the
Oh, that is
editor,
actually
there
kinda
is
nice.
display scale.
Sure.
150% is the default one. Although in my case, I'm going to use a custom scale of 250% or 2.5. In your case, this probably isn't necessary, but some people are watching this on a smartphone and it's going to be really hard to see if everything is so small. But if you have vision issues, this would be a good way to get started. So with all of that, I want to save and restart, and then things should be much more visible, even on the small screen. Alright, now with that out of the way, we can talk about the core of Godot, and that would be nodes and scenes. Nodes are the most basic building block that you can have in Godot. Those would be images, sounds, timers, animations, text, and there's a lot more what you can do here. Godot has a few hundred nodes, and every single one has one specific purpose. We are going to work with quite a few over this tutorial. The main thing you have to understand is that you have to combine nodes to create parts of your game. For example, our player is going to look something like this at the end.
I'm curious, like I'm kind of debating like maybe I should just try and figure out how to do stuff. But I'm probably just gonna get it's gonna be a waste of time, so it's like I don't necessarily want to just play out someone's
where we start with a
entire
parent node.
thing.
This one would cover the physics part, so the collisions most importantly.
Nobody's gonna be doing
After
this,
that,
like
we have a sprite 2D, and this would
nobody's gonna
simply
be
be
using my stream to follow the same course or whatever, so it's not a big deal, I don't think.
an image. So the image of the spaceship. After that, we have a collision polygon 2D, and this would be the collision shape. After that, we have a timer for the laser, we have a laser start position, and we have a couple of audio files. All of these combined are going to create the player ship. We are going to start with that very soon, but first of all, we also have to cover scenes. And those do two things. They organize and display nodes. For the first part, scenes organize nodes by basically being a folder for the node, and you can place a scene with nodes into another scene. This would look something like this. This is going to be the main setup of our game, where we, for example, have the player, we have the lasers, we have the meteors, we have a couple of boundaries, and we have the UI. Those are the main parts of the game. What is really important to understand is that this player is simply the entirety of all of these nodes in one scene and then placed into another scene. So the way you have to think about it is that all of this level is one scene, and then this player is another scene that happens to be inside of the parent scene. But inside of the parent scene, the player is simply going to be another node that you can very easily work with. That way, Godot makes it fairly simple to create really complex scenes, for example, for the player, and then insert them into another scene and not really worry about the complexity. Makes it really easy to organize your game. Besides that, scenes also display visual nodes. For example, if you have a sprite 2D, i.e. an image, then this one is going to be displayed via a scene. And that's basically it. If you understand these concepts, you already have a good start with Godot. So let's do some practice. Here we are back in Godot. And at the moment, the main thing you see in the middle is a 3D scene. Also at the top, you can see we have 3D selected, which isn't what we want. We want to have a 2D scene. And there you can see we have a 2D scene. Also, you can move around. If you hold the middle mouse button and move the mouse, you are moving the entire scene. And with the scroll wheel, you can go in and out. And that's basically all you need to move around in a 2D space. There isn't that much to it. Also, if you look at the top, there we have script, and this would contain our scripts later on. But for now, don't worry too much about it. All we need is 2D. So this would be an empty scene at the moment. There literally isn't anything in it. To change that, you want to look on the left side. There we can create a root node. And as a reminder, we always place a node into a scene. At the moment, we can select a 2D scene, a 3D scene, a user interface, or another node. If you click on Other Node, then you can see all of the available nodes inside of Godot. And there are quite a few. If you extend Node 2D, and there are a few more things you can extend, then you can see all of the available nodes that we could create. For example, there we would have a path, we could have a line, we can have some particles, we can have lots of different things. There's also static body 2D, character body 2D, basically physics bodies. But none of that is too important right now. So I'm going to close this dialog. And instead, I want to create a 2D scene. So if I click on that, we have a node 2D. This would be a very basic node. And if you want to learn more about the node you have selected, you want to look on the right. There we have the inspector. This one gives you all of the attributes of this particular node. For example, for this node 2D, we have a transform tab, where we have position, rotation, scale, and skew. And if you look at this scene, there we have this red cross dot thingy. This is the node 2D. It doesn't have a texture, so we can't really see what's going on. But if I update the position, you can see that this cross is moving. So we are indeed updating the position. Although this isn't what I actually want to do. So let's then do all of that. Instead, what I want to do is to actually add a sprite 2D to this node. That way we can see something. For that, you either want to click on this plus symbol or press Ctrl A on the keyboard. In either case, you're going to get a Create New Node dialog. And there you can attach any kind of node to the current node you have selected. And since there are so many nodes, usually what you do is you use the search function. In my case, I want to get a sprite 2D. If I now press enter, we have added another node to the scene. And this sprite 2D is a child of node 2D. Meaning whenever we are moving or rotating node 2D, i.e. the parent, we are also applying all of that to the child sprite 2D. And now if you look on the right, in the inspector, we have quite a few more things that we could be working with. Most importantly, we now have a texture. If you click on that, you get quite a few options, but most of these you don't really care about. What is a much better way to working with this is simply looking on the bottom left. There we have the file system. At the moment, we only have a single file, the icon.svg of Godot. This you can simply drag into the texture slot and it's already highlighted. If you now drag it in there, you can see we have the Godot logo. And now if you go to transform, you can see we have the same attributes again. And if I now change them, we actually can see something going on. So that feels significantly better. Once again though, this is not what I actually want to do. As a matter of fact, let's get rid of the sprite 2D. And now we are back to a simple node 2D. Since we want to make a game, we need to have a couple of art assets. Now in your case, you will have to download a folder and you can find the link to that in the description. In my case, I already did that. And what you get is a Space Shooter Assets folder, where we have audio and graphics. To import those into Godot, you can simply drag and drop them straight in there, and then you have the graphics folder with all of the contents. The same thing I want to do for audio, and make sure that you do this properly.
Wait.
So description. In my case, I already did that.
Where?
Now in your case, you will have to download a folder, and you can find the link to that in the description. In my
Where, dude? this one? I mean, I created resources to follow this. Okay. Wait, what? What? He said, I created resources to follow this tutorial. And then he says, I used resources from other users on itch.io. I mean, sure, whatever. That's fine. These bishops. Wait, what? Space Shooter Redux? Oh, whatever. Wait. Maybe I should check that. That's not what the other one was called, was it? Whatever. Right.
In my case, I already did that. And what you get is a Space Shooter Assets folder where we have audio and graphics.
Wait, I don't know if I have audio. Do I? I don't have audio. Maybe I can read about it later. Or make my own when we get there.
To import those into Godot, you can simply drag and drop them straight in there, and then you have the graphics folder with all of the contents. The same thing I want to do for audio, and make sure that you do this properly. So right now, by accident, I put the audio folder inside of graphics. To change that, simply drag and drop the audio folder onto res, then Godot is going to think for a second, and now we have an audio and a graphics folder. Audio is not too important for now, graphics is much more interesting. In there, for example, we have a couple of ships and you could select one of them. Doesn't really matter which one you choose. But for all of them, we have to go back to Node 2D, then press Ctrl A and select a Sprite 2D once again. I want to add one of the player ships. I'm going to use player ship 1 red. I think that's a pretty good default choice. If I drag this one over, we have a basic spaceship. Also, what you can do is to rename the nodes. For example, this shouldn't be a node 2D. Let's call this one the player instead. You could also rename the sprite 2D. If you double click on it, let's rename this one to player image. And by the way, in Godot, when you are giving nodes a name, you are usually using Pascal case, i.e. there's no space between the words, and every word starts with an uppercase letter. Although all of that is just convention. You could name them whatever you want. Cool. With that, we have one scene that contains 2 nodes, a node 2D and a sprite 2D. All of this I now want to save, and for that you can press Ctrl and S, or you could go to Scene and then Save Scene. In either case, you're going to end up with a Save Scene as dialog, and I want to create a new folder that I'm going to call Scenes. In there, I want to have a player.tscn file. That is the file ending for a scene. So click on Save, and now we have a player scene with a couple of nodes. What we can do next up is click on the plus next to the player. This would create a whole new scene. And if I zoom in, you can see that the blue border around it is the size of the window. That's going to become important in
Wait, what do you do?
What we can do next up is click on the plus next to the player. This would create a whole new scene. And if I zoom in, you can see that the blue border around it is the size of the window. That's going to become important in just a bit. For now though, I want to create another 2D scene. And this I'm going to rename right away to level. Also, I'm going to save it by pressing Ctrl and S, and this should be level.tscn. Godot always picks the name of the first node as the name of the scene, so level is what we also get in here. Cool. With that, we have 2 scenes, for level and the player. What I now want to do is to insert the player node into the level. And for that, besides the plus icon, you have a link kind of icon. If you click on that or press Ctrl Shift and A, then you can see the available scenes that we have created. At the moment, this is player and level, and I want to add the player to the level. And there you can see we have the player inside of the level. And by the way, you can move it wherever you want it to be. If you look on the left at the scene tree, you can see this symbol. This is telling you that this node is a scene created by the user. If you click on it, you get back to the scene where we can work with all of this in detail. And well, that is one of the most basic things you have to understand in Godot. That you have a scene with nodes, and then you can put one scene inside of another scene, and that scene would become basically just another node that is much more complex. But you can still add other nodes. For example, with the level selected, I can add another sprite 2D, and this I could rename to, let's call it BG. And this BG is going to be the background. For that, I want to minimize the shipped folder and instead look at other. There we have the BG. This BG I want to drag into the texture of this new sprite 2D, and now we have the background. And this we have to rearrange a bit to cover the entirety of the window, something like this. And well, now we have a background. Although you might have noticed that the player isn't visible anymore, and that is because of the order of these nodes. Basically, the further down a node is, the later it is drawn. Meaning at the moment, we are drawing the player and then we are drawing the background. As a consequence, the background is on top of the player and the player is not visible anymore. To change that, all you really have to do is drag the background before the player is being drawn, and now we can see the player again. Perfect. And that is basically all I wanted to cover for the basics of Godot. Let's do an exercise to make sure you have understood. I want you guys to create a meteor scene and place it anywhere inside of the level scene. The graphics for the meteor you can find in the graphics folder. There are quite a few textures, just select one of them, doesn't really matter. Pause the video now and see how far you get.
Just killed a meteoroid. Just kidding.
Alrighty, back in Godot.
Oh, shoot. Okay, those are backgrounds. Asteroid. Sure. All right, I have to save it.
I first of all want to create a new scene. And the parent node for this one is going to be a 2D node, or a node 2D, which I want to rename right away to Meteor. After that, I am going to click on the plus symbol and add a sprite 2D. This sprite 2D now has a texture, and for this texture I want to go to meteors, and there we can select one of them. I'm going to go with the first one, although it really doesn't matter. And if I do that, we have a meteor inside of the scene. After we have that, I want to save the entire scene as meteor.tscn, click on save, and now we have a meteor scene. This I want to place into the level. And for that, I want to click on the chain symbol and then add meteor.tscn. And now you might have noticed that the meteor is a child of the player, which is not what I intended. And as a consequence of that, the meteor is on top of the player. Now, I could simply move the meteor away from that, which would be a good start. But now look at what happens if I move the player around. The meteor moves along with the player. And that happens because the meteor is a child of the player. Whatever changes we make to the player would also be applied to the meteor. For example, if we go to transform and rotate the player, we are also rotating the meteor. The same would apply to the scale and to the position. Also skew, but I don't think anybody ever really uses skew. Anyway, I don't want to do any of those things, so let me reset all of them. To fix that, basically all we have to do is add the meteor as a child to the level, which you can do by simply dragging it on top of the level, and then the meteor is independent from the player. Or rather, the meteor is a sibling of the player, so they wouldn't influence each other whatsoever. Which is a much better behavior. But anyway, with that, we have the most basic part of Godot. Next up, in this part, we're going to start coding in Godot. And Godot supports quite a few different programming languages. Some really big ones are C++, C#, and Rust. However, by default, Godot uses what is called GD script. which is incredibly similar to Python. In fact, if you know Python, you basically know GDScript. Since that is the easiest one to get started with, it's also the one I will be using. However, for the purposes of this tutorial, I will assume that you already have some basic coding knowledge. All you really have to know is basic things like a function, for loops, methods, things like that. For this entire tutorial, we are never going to do anything terribly complex in code. So the most complex thing we are going to do is a for loop. It's really not going to be difficult. Even if you have never coded before, you should still be able to follow along, although it's going to be a bit more difficult. Now, what I would recommend is to have a look at some basic coding tutorial. Here's one for Python and one for JavaScript. Both will prepare you pretty well for using Godot. Just choose whatever, both would be perfect. Just choose whatever you like more. And if you happen to like my voice, I made the Python tutorial as well. Those two would connect reasonably well. But anyway, when we are writing code in Godot, we are always attaching a script to a node, and then this script can change the attributes of that node. This can be quite a few different things. For example, you could change the position, size, rotation, texture of whatever node you are working with. If there's an attribute in the inspector, you can change it via code. Let's have a look at that actually. So here we are back in Godot, and for now I want to work inside of the player. More specifically, I want to look at the player image. If you look at that and for example go to transform and hover over position, there you can see property position, all in lowercase letters. Or I could go to rotation, and there we have rotation or rotation degrees. You can also do the same thing for scale and for skew. They all work in basically the same way. All of them basically tell you how to target this property via a script. For that though, first of all, we have to attach a script to one of the nodes, and usually this happens to the parent node, although it doesn't have to be. All you have to do is have a node selected and then click on the script icon. If I click on that, we are getting a couple of options. At the top, we can select a language. By default, you only have GDScript. Then we have inherit. This one you usually leave as it is. Don't worry too much about it. Class name you can also ignore. The more important one is a template. There we have default and empty. And let's start with default. Godot actually explains right below what is going to happen. Template only means that we have a couple of basic functions inside of the script. Finally, the last important thing is the path to the script file. And usually you are storing the script in the same folder where you have stored the scene. In my case, I'm going to store player.gd inside of the scenes folder. And with all of that, let's click on create. And then you can see we have a couple of lines of code already. We have extends node2d, then we have underscore ready and underscore process, along with a couple of comments. To go over all of them really quickly. Extends node2d you have to have in there, and this node2d has to match with the node that it is attached to. For example, right now we have a script in the player node. And if I hover over this, you can see this node has a type node2d. Because of that, we want to extend in node2d to get all of the attributes of this node. Godot usually does this automatically, so you don't have to worry about it. Just make sure you don't delete it. After that, we have two functions, and a function in Godot is created via the func keyword. And then, like in Python, you have a semicolon. After that, you have indented code, and in this indented code, you can add whatever code you would like to have. On top of that, some functions are pre-made in Godot. You can see two already actually. Ready and process. Ready is being run when we are attaching a node to the scene tree. I.e., when we are creating a node, this function is going to be run. And process is going to be run on every single frame of the game. You can also see that this one has a delta parameter, and this one is inserted automatically. Via delta, you can account for frame rate differences. I'll talk about this in just a second. Now, basically what you would be doing. Inside, for example, the process function, you would target one of the attributes I just talked about. For example, if you want to have the position, you would simply type position. And Godot is giving you a couple of hints already. I want to have the position. And this position you could set to a specific value. Now for the position, we will need a vector 2, simply because we have x and y. Meaning in there, we want to specify an x and a y value. And just to have some random values, let's say I want to have x being 100 and y being 200. After we have all of that, Godot stops complaining, and now we are setting the position of this player node 2D to 100 and 200 on every single frame of the game, which isn't going to be terribly useful, but for now it's a good start. So now, if I return to 2D, right now nothing is going to happen. That is because we are not running the script, and for that you have to look at the top right. There we have a couple of icons. The most important one is all the way on the left, and this says Run Project. If you click on that, you are going to get another dialog where we have to select a default scene. What that means is that Godot wants to have one scene that will be run when the game starts. And there we could select a scene or select the current one. Now in my case, I want to click on Select and then select the level scene. And now we can see we have the actual window. So that's a really good start. On top of that, what is really important is the position of the ship. If you look at it closely, we have the ship right here. However, if I go back to the editor and look at the level, we can see that the ship isn't in this exact position, although this is quite difficult to see. Let's close the game again, and when we are placing the player, I want the player to be in the top left. And now if I run the game again, which I can do by clicking on the triangle, now we can see that the player is still in the other position. And that is because of the script that we have written that places the player always in this particular spot. And also, I should explain that the window is a grid that starts in the top left, meaning when we are placing the player 100 pixels to the right and 200 pixels down, we are starting from the top left. But other than that, we simply have basic coordinates. Also, on top of that, if you go to Project, Project Settings, and then under Window, you can set the window dimension, and that window is a bit small, that looks much better. By default, the viewport width and height is 1152 by 648. I think a much more common one would be 1280 by 720. And now, if you close this dialog, the blue border around it has increased by a little bit. If I run the game again, it's not going to be terribly visible. Or actually it is. We can now see that the background isn't entirely covered anymore. And that we can fix quite easily. All we have to do is drag the background so it covers everything. Let's try. And that looks almost correct. So with the background selected, I want to go to Transform and then increase the scale by just a bit. And I should show my mouse for all of this. So we are in Transform, and I clicked on Scale and simply drag this one up a bit. So we are covering the entirety of the background. If I now run this again, this is much better.
So
cool. With that, we can return.
So if this... Alright, the position is based on this center. Is there some way I can change that? Oops.
To script and then have a look at what else we can do. At the moment, we are always placing the position of the node 2D, to be more specific, the player node 2D, at this particular position, which arguably isn't too helpful. What we can also do is change the position. And this you can, for example, do with plus equal. We want to change the position by a certain amount on every single frame of the game. For that, we will still need a vector 2 for the direction. For this one, let's go with 1 and 0. That way, we are only going to the right, although this would be very, very slow. So I want to multiply all of this with, let's say, 50. And now if I run all of this again, you can see that the ship is moving to the right. Although, if I run all of this again, you can see the ship is all the way in the top, meaning the starting position was this point, which should make sense because this is where we are placing the ship by default. You can find all of that in the 2D scene, in the level. This is the starting position of the ship. And all we're doing is moving the ship to the right on every single frame of the game. We could account for that in a couple of different ways. For example, what we could do is place the ship somewhere here, and now if we run the game, the ship starts.
The heck? What? Okay, why? Because that's... Wait, what? Okay. Right. Oh, I'm confused. And how is that 0, 0? It's literally at like -1, -3, or whatever. Oh, there it goes. Okay. So I guess the position in the scene is actually... Yeah, because if I position it like... They have different frames of reference, I guess. Oh, there it is. -4, -15. Oh yeah. Okay, good.
From this position and moves to the right. What we could also do, if I return the ship to the origin point, I could look at the script and work inside of the ready function. This one is only going to run once when the scene is ready. And in there, we could target the position again, and then set it to a certain value, once again via a vector 2. For example, this could be, let's say, 100 pixels from the left and 500 pixels from the top. If I now run all of this again, we have the ship starting at this bottom bit. And that's basically all you have to know about the ready function and the process function. The only difference between them is that process is being called continuously, while ready is only called once. Also, what can be quite confusing for beginners is that at the moment we are working inside of the node2d of the player. So we are attaching a script to it. But when you look at the top, we have the level scene selected. And what would be more appropriate here is to have the player scene open because this is the one we are working in. The thing you have to understand is that we can have a scene open and the script might be for another scene. This can be a bit confusing. So I hope this makes sense. There are two important concepts that we have to cover. The first one is delta time. This one helps you to account for frame rate differences. So if I run the game, my spaceship has a certain speed, but on your computer this might be much faster or much slower, depending on the hardware of your computer. Basically, the problem is that Godot is trying to run this line as fast as it can. On a fast computer, it might be able to execute this line 1,000 times. On a slow computer, it might only be able to do it 30 times. And since we're updating the position on every single frame, if your computer can run faster, it will do this operation more often per second. And to account for that, you have to add delta time. And if you spell it correctly, that will also help a lot. Delta is the elapsed time since the last frame. The comment here explains this one quite well, actually. This difference is going to be smaller the faster your computer is running. For example, if your computer can run the game at 1000 frames per second, the difference between each frame is going to be 1 millisecond, a very short amount of time. However, if you're going to run the game at 60 frames per second, the difference between each frame in terms of time is going to be about 16 to 17 milliseconds. All of this combined basically means that the faster your computer is, the smaller delta time will be. And if your computer is slower, delta time will be larger. Because of that, delta time will counteract this line being called more often on a faster computer. And if you're interested in the math, here's a slide that explains all of this in a bit more detail. Just pause it now and read through it. But anyway, if I run the game again, we can see that the ship is now running significantly slower. However, it should run at the same speed on any computer, which is the really important thing that we wanted to cover. And that's the first issue I wanted to address. Next up is that sometimes we only want to change an attribute of the sprite 2D and not of the entire scene. So at the moment, we are changing all of the children nodes of this player. If we had multiple, they would all go along with this parent node. As a matter of fact, let me duplicate the player ship a couple of times, which I can do with Ctrl and B. And let me simply place all of them somewhere like this. If I now run the entire game again, we can see that all of the ships are moving at the same speed. And I should have moved the last one something like this, so you can actually see it. There we go.
Right. Yeah.
All of the ships, or rather, the entire scene is moving to the right. And this is not necessarily what you want. Sometimes you only want to target one specific child node. You can do that in two ways. One way would be to use the function get_node. And then Godot is already giving you a couple of default options. You want to have a string with the name of the node. There we have the player image. Once you have that, you can use this like any other node. For example, you could update the rotation and increase it by a very small amount. Let's say 0.1, and don't forget, also multiply this by delta. If I now run all of this again, we have the ship rotating by a certain amount. And I suppose, let me duplicate player image again and move it to a slightly different spot so we can see what's going on, by a certain amount. And I suppose let me duplicate player image again and move it to a slightly different spot so we can see what's going on. If I now run the game again, only one of the ships is rotating because this is the only node that we are targeting via script. Although you don't really see this kind of line very often because it's kind of extensive for what you want to do. Instead, what is much more common is a $sign and then the name of the node. So in my case, player image. This is doing the exact same thing. It simply gives you a node and then you can work with this node. And this is much easier to read and shorter, and you are getting the same result. Hence, this is the much more common way to address a node. Also, what you could be doing, if I get rid of this again, you can simply drag and drop a node into the script, and then you get the same outcome, which can be quite handy if you have a very long name. But alright, with that, we can target one specific node or all of a scene. Also, I don't want to have the player image 2 anymore. We only want to have a single player image. And alright, with that, we have already covered a really important starting point. But when it comes to coding, there's quite a bit of material that you have to understand. And Godot is fully aware of that, and because of that, in the top, we have a help bar. And there you can click on Search Help. If you open that, you can look at a lot of different things. Basically, whatever you could be looking at, for example, if you want to know about a vector 2, then Godot is giving you quite a bit of information about it. Basically, the documentation is built right into the editor. And working with this is incredibly important. So we are going to do an exercise right away. I want you guys to read through the documentation and figure out how to get input. There are quite a few different ways of doing that. Just try to find one way. It doesn't really matter which, just make sure you can get input and move the ship from that. Pause the video now and play around. See how far you get.
Oh, what was the other thing I saw? Okay, so let's gosh, this is so long. Wait, so if I did this and said I don't think this is right at all, but hey Katie, how's it going? Um, wait, so it would be like, let me find that vector again. Darn it, where was it? Yeah, I don't really know how to use that. Oh yeah, I guess I probably need to run a function. Cause this, wait. Let me see. Oh, interesting. If event is input event mouse motion, position equals event position minus vector 2 0 16. Dude, I don't know what the right thing to do is. Feels like using something like this doesn't make much sense. Okay, that is what I'm supposed to do then, I guess. Physics process. If input is action pressed, move right. Move as long as the key button is pressed by position. Add speed times delta. Okay. I'm gonna save that for later. Wait. Wait, if okay, so wouldn't it what's the difference between physics process and process? Called each physics frame. Oh, right, because physics frames are going to be separate. Since called each physics frame with the time since the last physics frame as argument delta in seconds equivalent to node physics process. Called each process idle frame with the time since the last process frame as argument in seconds. If implemented, method must return. Okay, whatever. Okay. Yeah, I can't just get rid of it. Yeah, speed not declared. I know. remember any of the GG script I did before last week. Ugh. Oops. You know what? I'll put this back on. Okay, but I think this is assuming I've defined these in the script. I don't really know. Oh, this is that. Okay. Oh yeah, that's how you do. Like that. So move up. If I go to input map and I say move up, oops, not what I meant. Move up. Start with a character body 2D with two children, by 2D and collision shape 2D. Would that actually change anything? Here, let me try. I don't know. I'm just gonna watch what he does.
Back in Godot. To get started, I want to search help and then type in input. This is going to bring me to an input class, which looks pretty good. There we get a few descriptions, and if you scroll down, you can get all of the input methods inside of Godot. For example, a fairly easy one is action just pressed or is action pressed? This one looks for one specific action, which should be just a name of a string. We can specify that later on. The thing we are going to use in just a bit is going to be called getVector, but that's going to come later. For now, let's try to figure out how to use isActionPressed. If you click on that, you get a bit more detail on what this particular method is doing. So, let's use it. And for that, I want to work inside of the player. Specifically, I want to work inside of the process function. In there, first of all, we will need the input class. And in there, if you press dot, you get the different ways to get input. For example, in there, we could check for isActionPressed. After that, we are going to need a name for what kind of input we are looking for. Godot has a couple of default ones. For example, UI down is simply the down key on the keyboard. And once we have that, Godot is going to return either true or false depending on this button being pressed or not, which we can print. So let me wrap all of this into a print statement, run the entire code again. And now if you look at the bottom, there we have an output, and by default it's false. But if I press down, it is going to be true. And if I release the key, it's going back to false. And this is working pretty good. Although this by itself doesn't do very much, but if we put all of this into an if statement, and then indent the 2 lines below, then the ship is only going to move and rotate if we are pressing the down key. So let's try. And now by default, the ship doesn't do anything. But if I press down, the ship is moving. If I release the key, it stops moving, and so on. That's basically all you have to know about it. Although this would be a bit too basic of an input, we want to have something slightly more complex. For that, we can look back at input, and if I scroll up quite a bit, we are getting back to the top where we can see all of the methods. And in there, we have one called getVector. This is the one I actually want to use. This one takes 4 arguments for negative x, positive x, negative y, and positive y. Basically all the 4 directions. And then it is going to return a vector with the direction we have specified. That way we can get all 4 directions in a single line of code. The way you would be using that one, back inside of player.gd. I want to create a new variable, which I'm doing with the var keyword. Let's call this one the direction. And the direction we are getting via input and then get vector. Now we have to specify 4 inputs. And we could be using the default options here. For example, there's UI down. We would also have UI left at some point. But those are kind of clunky. A better way of doing that would be in project settings, and there we have an input map. This allows us to specify custom inputs. The way you would be using that is you are first specifying a new action. For example, left. Then you get a new action, and to this action you can add a key, which you do by pressing this plus icon. And then you can simply look through what kind of key you want to associate to this action. Although most of the time in this dialog, you simply have to press one keyboard button, and then Godot is giving you this key. So if I press left, we are getting the left key. If I now click on OK, we have added one physical keyboard button. You could, if I click on the plus again, also add other kinds of input. For example, if you want to have a joypad, this would also work perfectly fine in here. But that's not what I want to do. Instead, I want to create a few more actions. We want to have an action for right, an action for up, and an action for down. And then for all of those, I'm going to click on the plus icon, and then simply press right on the keyboard for right, for up. I do the same thing, except now I press up. And finally, the same thing for down. For this one, I'm going to press down, and now we get left, right, up, and down with the associated actions. That's all I need in here. And now, if I go back to my script, and if you press Ctrl and Shift, you get a bunch of hints. And there you can already see we have down, left, and right. Left is the first one we have to include. Now I press up, and finally, the same thing for down. For this one, I'm going to press down, and now we get the associate. And if you press Ctrl and Shift,
what? Doesn't do anything. Control and Shift.
My script. And if you press Ctrl and Shift, you.
Oh. Oh well. Okay, so negative x left, and then come on. What? Why is it not?
You get a bunch of hints, and there you can already see we have down, left, and right. Left is the first one we have to include here. This would be negative x. Next up,
Negative
we want to
y.
have positive x, which is going to be right. And all of those you can find inside of input.
Oh.
There you can see negative x, positive x. Next up, we have negative y. And be careful here, in Godot, negative y is going up, because the coordinate system for the window starts in the top left. Can be a bit confusing sometimes. But basically, we want to have up for this one, and finally, the last option is going to be down. And I am running a bit out of space, so let me expand this window. And what you can also do in the top right, there's an expand window. That way you have a bit more space. Alright, with that, we are getting a vector. And let's print what we are actually getting. So I want to print the direction, now run the game. And now we get 0 and 0 by default. But if I press on any of the arrow buttons on the keyboard, there you can see we get a direction that looks pretty accurate. And also if I press down, you can see the ship is moving, and that happens because of this if statement. Although that we don't actually need anymore, so let me get rid of all of this. Instead, what we want to do is get the position, and then add the direction, and multiply it with some kind of speed, let's say 500. Also, don't forget, we want to multiply all of this with delta. And now if I run all of this, we can see that the ship is moving along with my keyboard input. That is looking really good. Nearly done with this part. The last thing I want to cover is that this 500 right now feels a bit generic. I would rather have a variable that stores the speed. And for that, all the way at the top, before we are working with the functions, you can specify var speed and then set it to 500. And this would be a global variable. It would be available in all of the functions. However, this direction would be a local variable. It would, for example, not be available inside of the ready function. If you have no idea what that means, look up scope. It's quite an easy concept. In my case, I want to multiply the direction by the speed by delta time. And the output is going to be identical. So that's still looking really good.
It takes me such a long time.
On top of that, what you can do in Godot, before you are declaring a variable, you can add export. And this, in terms of the game, is not going to make any change. However, what it does do, if I minimize the code again and go to the 2D scene, and select the player, we now have another attribute inside of the inspector. 500 by default, but I can change this to 200, run the game again, and now the ship is going to move significantly. Really good. On top of that, what you can do in Godot, before you are declaring a variable, you can add export. And this, in terms of the game, is not going to make any change. However, what it does do, if I minimize the code again and go to the 2D scene and select the player, we now have another attribute inside of the inspector. 500 by default, but I can change this to 200, run the game.
What's in here? Okay, yeah.
Again, and now the ship is going to move significantly slower. Basically, via export, we are declaring that a variable should be changeable via the inspector, which for some more complex games can be incredibly useful to fine-tune things. Although you don't have to use it, it's a fairly subjective thing if you like it or not. Okay, one last thing before we finish this part, and that is, when you are declaring a variable, sometimes you want to make sure that you only have one data type. For example, I want this speed to always be an integer. To make sure that you always get that, you can add a semicolon, and then you specify the type. For example, this would be an integer. That way, this number can change, but it always has to be an integer. For example, what I couldn't be doing inside of the ready function is assign speed to a value like test. If I do that, Godot is going to give me an error that we cannot assign a value of type string as integer. Now, to make this a bit easier, what you see a lot in Godot is this kind of setup. What that means is that whatever value we initially assign to this variable is going to be the data type of this variable. Meaning for speed, we are assigning it an integer when we are creating it. And this data type cannot be changed anymore because of this semicolon. Because of that, this line is still going to throw an error. But if I remove it, it disappears and Godot is happy again. I can now run all of this, and you can see the game runs just as before. And I guess a speed of 500 feels significantly better. So let's try this again, and there we go. Now we can move the ship around. And with that, we have made quite a bit of progress. In this video, we're going to cover physics and signals in Godot, two topics that are really important on their own and work incredibly well together. Let's get started with basic physics. In Godot, there are 4 nodes that deal with physics, at least in 2D. Area 2D, static body 2D, character body 2D, and rigid body 2D. An area 2D is just an area. It doesn't really do much on its own, but it's really good for detecting collisions. Next up, we have a static body 2D, and this one has collisions, but it cannot move on its own. For that, we have a character body 2D. This one does have collisions, and it can move. That movement, by the way, happens via code. If you want to have physics-based movement, then you want to have a rigid body 2D. This one has collisions and moves, and all of the movement happens via physics. What is also really important is that all 4 of them need a collision shape, but that we can explore right away in Godot. Here we are, and I want to start with the first important node, and that is a character body 2D, because this is what the player is going to be. For that, inside of Godot, at the moment, the parent node of our player is simply a node 2D. But this I want to change, and for that, I'm going to right-click on this node, and then go to change type. Then we get to the dialog again, and for this one, I want to have a character body 2D. If I now press enter, we are going to get a warning sign that this node has no shape. That we are going to worry about in just a second. First of all though, when I open the script, at the moment, we are extending a node 2D. This is not correct anymore, so this has to be a character body 2D. If we didn't change that, we would be getting an error message. Next up then, inside of the 2D editor, what we have to make sure is that we account for the warning that Godot is giving us. Meaning, we have to give this node a shape, and this you can do in 2 ways. If you add another node, you can add a collision shape 2D or a collision polygon 2D. Both would work, and let's start with the easier one, a collision shape 2D. If I double click on this one, nothing happens inside of the editor. Instead, what we get is another node, and this one has another warning that we have to provide a shape, and this happens inside of the inspector. There we have a shape. If you click on the drop-down menu, we can select a shape for this particular body, and basically what you want to do is select a shape that works reasonably well with it. I suppose we could go with a capsule shape, and then you get a shape, and then this shape you can modify to whatever you need, and that I think looks okay. Not amazing. But now we don't have a warning anymore, so that's a...
Dang. How do I make... Oh, there we go. Right? Okay. Am I able to... Dragon points. We add. Okay, yeah. Okay, this is, at this point, it's bad game design. There's no reason that I should be doing it like that. Let me just do it a little more simple. Okay. Wait, no. That's... Shoot, I don't know. Oh my gosh, I don't know which one's which. Oh boy. What have I done? Kinda wanna restart at this point. Oh my gosh. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 19. That's a lot. There's probably something wrong with me. Well, I clearly only needed 16. Are those on the same spot? I think so. It's good enough. More than good enough.
A really good sign. Although I don't like this collision shape, so let's get rid of the collision shape 2D and replace it with a collision polygon 2D. With that, we have basically the same problem that we have to provide a shape, or in this case, a polygon 2D. To provide that one, you want to look at the top, because there we can draw a couple of points if you click on the plus symbol.
No, that would have saved me so much time.
You can simply outline a shape for the body that you
I
want
was
to
like,
create.
there's got to be some
It doesn't
way
have
to
to
do
be
this.
too precise, but do it reasonably okay.
Oh well.
Something like this would work just fine. And with that, we have a collision shape, so that's pretty good. This would now be the physical shape of this node, meaning we can work with collisions, but for collisions, we need at the very least 2 bodies.
Wait a minute. If I got rid of this one, it'd still work. Okay.
And for that, inside of the level, I want to use physics bodies to prevent the player from going outside of this area. Because at the moment, if I run the game, the player can simply leave the screen, which shouldn't happen. For that, inside of the level, I am first of all going to add a new node 2D. But this one, we have a collision shape body that you want to create. It doesn't have to be too precise, but do it reasonably okay.
Concave polygon. This is a sign. Polygon-based shapes are not meant to be used nor edited directly through the collision shape 2D node. Please use collision polygon 2D node instead. Okay. Well, okay. What was the point of this being an option then? That's annoying.
Some 2 bodies. And for that, inside of the level, I want to use physics bodies to prevent the player from going outside of this area. Because at the moment, if I run the game, the player can simply leave the screen, which shouldn't happen. For that, inside of the level, I am first of all going to add a new node 2D. But this one is just for organization's sake, so I want to change it to, let's call it, borders. In there, as a child, I'm going to add a static body 2D. This one, once again, is giving us a warning that there's no shape. To fix that, we have to add a child, which has to be a collision shape 2D. Or a polygon, both would work, but a shape for this one is better. Because all we really want is a rectangular shape. Let me zoom in, and there we can see we have an area, and on this one, we can change the size, or we can change the position. Also, if you look at the inspector and click on the shape, you can customize the size with specific numbers. And let's do this one for now. I want to set a height of 720 because I know that's the height of the window. And then this is going to be the right side of the screen. Something like this. You don't have to be too specific here, but do it reasonably okay. And with that, we have a right side collision. However, if I run the game and I try to go all the way to the right, we can still go over this border. So something isn't right yet. And that is because inside of the script, we are updating the position of the player ship. And this is not how character body 2D is supposed to be used. Instead, what you are supposed to be doing is set a velocity. Velocity is an inbuilt attribute of a character body 2D, meaning we just have to assign a value and then we get something useful. In my case, all I really want to do is give it the direction multiplied by the speed. Delta we don't need because Godot adds this one automatically. With that, we can get rid of the position entirely, and all we have to do now is call one method called move and slide. This one applies the inbuilt velocity to get actual movement. And now, if I run the game again, I can still move around just as before. However, if I now go to the right, Godot does respect the collision, and that feels really good. Cool. I am very happy with that. What we can do now as well is place the player a bit more to the center,
Expected
something like this.
Intended block after function. This was... What did he do? Move and slide. Huh. Oh, equals. Wait, what? 20? What do you mean 20? Oh, because I have this... Whoops. Should probably get rid of that. Or give pass on it. Now it'll work. Cool. Oh gosh. Delete that. Should probably make these ones longer. Let's see. 1330. Or no, because it's double. 1380. Oh, no.
This one applies the inbuilt velocity to get actual movement. And now, if I run the game again, I can still move around just as before. However, really good is place the player a bit more to the center, something like this, and then duplicate the static body 2D, because besides a right side, I also want to have a left side. Then I can duplicate it one more time and move it all the way up here. Although the sizing for this one doesn't
right,
align
I should have
anymore.
duplicated
And for
this,
that, we can drag the red dots and change the size. Although this doesn't work perfectly
it's fine.
So, what happened here? Basically, when you are copying these nodes, they all keep a reference to each other, which means when you're changing one of them, you are changing all of them, which usually isn't what you want. But you can fix it by simply getting rid of the shape and then assigning it a new shape. Now we get a completely new shape and can do with this whatever we want. And for this one, I simply want to cover the entire top side, something like this. And by the way, if you hold Alt and drag one of these points, you mirror the other side, which is super handy. Finally, I have the last shape.
Wait, if you hold Alt?
Drag one of these points, you mirror the other side. Wait, if you hold Alt and drag one of these points, you mirror the other side, which is super handy. Finally, I have the last shape, and you can also move them via the mouse. And if you hold Shift, they're moving a bit faster. So this is another way to move them around, and I want them here. Cool. With that, I can run the entire game again, and now the player is not able to leave the screen anymore. Cool. So that feels quite a bit better. Now, this isn't exactly the most elegant way of constraining the player to the window.
All right. I am gonna stop here. Save all states. There we go. Now I think I can quit without it doing anything bad. Alright. See you later.